quadratic equations by factoring, because that's obviously the first thing you always want to check for. Solving a quadratic equation by factoring. Remember, you set one side of the equation equal to 0. And then you solve the other side by factoring. Use your zero product property. So again, always make sure you have a 0 on one side, which is what I have right here. So now, how do I factor x squared minus 3x minus 4? That's going to factor into what? That factors into what? X what? Minus 4 and an x what? Plus 1. Then you can use your zero product property and you can set each factor equal to 0. So then x is going to be equal to 4. X is also equal to negative 1. Okay? So any questions on solving by factoring? All right, let's take a look at number 2. Again, you still always want to check for a GCF first. Is there a GCF you can factor out in problem number 2? You can take out a what? 2. So when I take out the 2, that's going to give me a 9x squared minus 1. And remember, you don't stop after you pull out a GCF. You then need to look inside the parentheses and see if you can factor further. How can you factor 9x squared minus 1 further? That's a difference of 2 squares, correct? So I can factor that into what? 3. Yep. All right, so I can factor using, remember, difference of squares. One parentheses is a plus, the other is a minus. And then I can set each factor equal to 0. So then x is going to be equal to 1/3. X is equal to negative 1/3. No, the only time, good question, the only time you would have to take into account this 2 is if you had a variable with it. If you pulled out an x, then you'd have to set that x equal to 0. All right, what do you have to do in number 3 first before I can factor? I'm going to have to do what? Add the 6. So I've got to get that 0 on one side. So 5x squared minus 13x plus 6 is equal to 0. So now, remember, this is where a lot of you make that little x. Remember, you want to multiply 5 times 6 together, which gives you 30. And you want to find the factors when added together will give me a negative 13. So what numbers multiplied together will give you a 30, but when I add them together will give me a negative 13? Negative 10 and a negative 3. So this is where then you expand this out and you write it in terms of 4 terms. Remember, we're going to rewrite negative 13x as negative 10x and negative 3x. So 5x squared minus 10x minus 3x plus 6 is equal to 0. And then you do your factoring by grouping. So I'm going to pull a 5x out of my first set of parentheses. So I'll give me an x minus 2. What GCF am I going to pull out of the second set of parentheses? I'm going to pull out a what?
3.
Negative 3. Because remember, with factoring by grouping, you want these two parentheses to be identical. So now I can do factoring by grouping again, pulling out that x minus 2 GCF, and that leaves me with a 5x minus 3 is equal to 0. So any questions on, again, that's factoring a trinomial where that leading coefficient is not equal to 1. You may have been taught another way to factor trinomials where the leading coefficient is equal to 1. If you do it a different way, by all means continue doing it. I'm not going to say you must factor this way and this way only. But as long as you know how to factor it, that's what I care about. All right? So then when I set each factor equal to 0, x minus 2 equals 0, 5x minus 3 is equal to 0, so x is equal to 2, x is equal to 3/5. Okay? So now let's take a look at number 4. What do you have to do first in number 4? You have to do what? You have to get a 0 on one side, so add that 12s. Okay? You guys go ahead and finish that for me. Solve that by factoring for me. So we'll come up with negative 2/3 on that one. So now remember, this is a unique, if you remember back to Algebra 1, perfect square trinomials. There's a certain pattern. You don't have to go through that whole x method if you recognize a perfect square trinomial. If your first term is a perfect square, your last term is a perfect square. So the square root of 9s squared is 3s. The square root of 4 is 2. If you multiply your two perfect squares together, so 2 times 3s is 6s, and double it, that gives you the middle term. So that's a pattern. Again, you can still continue to use that x if you don't recognize it, but that is a perfect square trinomial. What are you going to have to do in number 5? What do we have to do in number 5? We're going to have to do what? Get what on one side? We have to get a what? To solve this by factoring, what do we need on one side? We need to have a what? 0. So I'm going to add y squared. Remember, I'm going to add y squared to its like term of 2y squared, so that gives me a 3y squared. I also have to subtract y. So that gives me a minus 5y. Minus 8 is equal to 0. So sometimes you may have to move more than one term over, but you always want to make sure you have that 0 on one side. All right, so you guys go ahead and finish that by factoring. Up with solutions to be 8/3 and -1. Don't forget, guys, if you're using that technique using the x, don't forget, if there's no GCF to pull out, you do have to consider factoring out a 1. You can pull a 1 out of everything. All right, so any questions on number 5? So any questions on how you can use solving by factoring? Again, that should be reviewed. You guys have been doing this since Algebra 1. All right, another method you guys learned to solve quadratics is by isolating the square. So again, if you just have a squared term and a constant, remember, you can take the square root of both sides of the equation. Don't forget your plus or minus when you do this square root method. So don't forget you have to take the plus or minus. So again, the idea is you want to isolate x squared. So what are we going to do in the first step to get x squared by itself? We're going to do what? Subtract 1. So 2x squared is equal to 16. Then what? Then what? Divide by 2. So x squared is equal to 8, and then what am I going to do to both sides? I'm going to take the what? Square root. So then x is equal to plus or minus square root 8. Remember, always check to see if you can simplify your radical, which you can. Square root of 8 simplifies to 2 square root 2. So there's your final answer. Big common error I see with this is you guys forget that plus or minus, which when we were solving those trig equations back in Unit 5, we had to go back over that as well. All right, so let's take a look at number 7. What's going to be the first step here? I'm going to have to do what? I'm going to add 12. So I have negative x squared is equal to negative 75. Divide by a negative 1. Remember, always make sure x squared is by itself before you do that square root. And then you take the square root of both sides. So then x is equal to plus or minus. You can simplify the square root of 75. It's got that 25 perfect square factor, which when you do your factor tree, you break out that 5 times 5. So you end up with 5 square root 3. Right? Again, you can use this when you can't, factoring doesn't work. You can use this as long as there's no just plain old x to the first in the equation, as long as you have just a base raised to the second power. What's going to be your first step to get v squared by itself in number 8? What's going to be your first step? What's the first step? Add 1. So v squared over 12 is equal to 12. Then what? How do I get v squared by itself? I'm going to have to do what? By 12. Multiply the whole equation by 12. So v squared is equal to 144. Again, now I can do the square root. So v is going to be equal to plus or minus, and 144 is a perfect square. What is the square root of 144? 12. Or you'd have to do your factor tree if you didn't recognize it as a perfect square. So any questions on 8? Now remember, you can also use isolating the square when you have parentheses raised to the second power. So how am I going to get these parentheses by itself? What's going to be the first step here? I can't distribute the 2. You're breaking order of operations. But you can get the set of parentheses by itself by doing what? How can I get, again, it's 2 being multiplied by the parentheses. How can I get the parentheses by itself? Divide by 2. So I have x minus 3 to the second is equal to 4. Now, how do I get rid of the square? What can I do to both sides? I can take the what? Square root. So x minus 3 is equal to plus or minus. You still have to remember that plus or minus. And what's the square root of 4? 2. How many equations do I have to solve here? 2. Remember, you have to break this out. You have x minus 3 is equal to a positive 2. You have x minus 3 is equal to a negative 2. Don't forget what that plus or minus means. You have to consider that one solution will have a positive 2, the other one will have that negative 2. So x is going to be equal to 5, x will be equal to 1. So any questions on 9? So number 10, again, to get the parentheses by itself, what's going to be your first step? You have to multiply everything by a what? 4. So we have b minus 8 to the second is equal to 28. Then what am I going to do? I'm going to take the square root. So we have b minus 8 is equal to plus or minus the square root of 28. Can I simplify the square root of 28? Yes. 2 square root 7. The plus or minus stays in the front. So then b is going to be equal to 8 plus or minus 2 square root 7. Or you could write as 8 minus 2 square root 7, 8 plus 2 square root 7. All of those are equivalent answers. Okay. You guys go ahead and try number 11 for me. Go ahead and solve that one for me. So did we all come up with r is equal to 7 and r is equal to negative 2? Okay? Again, 81 is a perfect square, so you do have to break this up into the positive 9 and negative 9. So we add our 5, which gives us 2r is equal to 14. So r is equal to 7. Add 5, that gives me negative 4, and then divide by 2. So is it coming back a little bit, solving these equations back from your Algebra 2 days? So another method that you learned, which is my least favorite, is the quadratic formula. So when isolating the square doesn't work, factoring doesn't work, this is solving your quadratic equation by factoring. So again, in case you forgot, here's your quadratic formula. Remember, you still have to make sure you set one side of the equation equal to 0. So factoring in quadratic formula, you have to have a 0 on one side. So the first thing I have to do is I have to subtract 5 here. So now remember, when you are solving by quadratic formula, remember you're looking at it in standard form. Ax squared plus bx plus c is equal to 0. So the a value is going to come from the number in front of x squared. B is coming from the number in front of x. C is your constant, does not have a variable with it. So looking at this equation, that once I set it equal to 0, what's my a value going to be equal to? A will be equal to what? 2. B is equal to 1, and C is equal to, careful, negative 5. Okay? So now take those values and plug them into the formula. So a is equal to negative b, which is negative 1, plus or minus the square root. B squared minus 4, a, which is 2, c, which is negative 5. All over 2 times a, or 2 times 2. So simplify what's under the radical, negative 1 plus or minus square root. So this is going to give me a 1. Negative 4 times 2 is negative 8. Negative 8 times negative 5 is a positive 40. So 1 plus 40 is going to give me 41 under the radical, all over 4. You can't simplify the square root of 41, so that is your final answer. Okay. So any questions on solving by quadratic formula? No. Okay. So this is the little bit of news. So up till now, it should have been a review. So now, another way to solve quadratic equations is by completing the square. So completing the square actually has a lot of other applications besides just solving quadratics that we're going to be using throughout the semester. But what we're going to concentrate on using it for is, and again, I like completing the square. I'll go to completing the square over quadratic formula any day. The issue that you guys run into with quadratic formula is, yes, you guys can do your plugging and chugging into the formula, but where you guys get tripped up is the simplifying. You guys run into trouble simplifying the radical and then simplifying the fraction. So completing the square will give you a much more simplified answer, and it's a lot shorter once you get the process down than using the quadratic formula. So before we talk about completing the square, let's talk about x minus 8 to the second power. If I asked you to multiply that out, would it just be x squared plus 64? What does this square mean? This square means you're going to do what? Take x minus 8 and do what with it? Multiply it what? By itself. Remember, when you see a binomial to the second power, it is not just distributing the exponent into the parentheses. You have to FOIL this. So you have to multiply x minus 8 times x minus 8. So when you multiply that out, that's going to give you an x squared minus 8x, which is a minus 16x, plus 64. You never, ever, ever distribute that exponent into a binomial. All right? So you guys go ahead and do the next one for me. Tell me what x plus 3 to the second power is going to be. Did we all come up with x squared plus 6x plus 9? Okay. Again, x minus 12 squared is x minus 12 times x minus 12, which will be x squared minus 24x plus 144. Okay? So now, these trinomials that I got, when I multiplied out these binomials to the second power, have a special name. I mentioned it a little bit ago. It is called a perfect square trinomial. Anytime you multiply out a binomial to the second power, it's going to produce a perfect square trinomial. And again, we call it a perfect square trinomial because you can factor it as a binomial squared. So again, when I have that x minus 4 squared, for example. That's kind of the basis of how completing the square is going to work. This is our procedure that we're going to do. First of all, completing the square only works is if the coefficient of x squared is a 1. If it's not, you're going to divide it by the coefficient first. We're going to move the constant on the right side. So not like factoring or a quadratic formula, you don't need that 0. We're going to move the constant to the other side. And what you're going to do is you're going to create a perfect square trinomial. You're going to take half the coefficient of x squared and add it to both sides. And then solve. So for example, let's take a look at number 13. So the first step, what you want to do, x squared has a coefficient of 1. So I don't have to worry about dividing anything. I need to take this plus 24 and move it to the other side by subtracting. So that's where I get the negative 24 from. So you always want to move your constant to the other side. So now this is where the third step comes in. This coefficient of x, I'm going to take 10, divide it by 2. So that's where it takes half. And then I'm going to square it. So that's the step that you have to do in completing the square. You take the coefficient, whatever number's in front of x, you divide it by 2 and you square it. So what is 10 divided by 2? 10 divided by 2 is what? 5. And then I'm going to square it. And what is 5 squared? 25. So I need to add 25 to both sides of my equation. What you've created right here is a perfect square trinomial. That's what you're trying to create. You're trying to create a perfect square trinomial on the left-hand side. So now what I want to do is I want to factor this. Well, what does x squared plus 10x plus 25 factor into? That factors into what? Again, so what's x squared plus 10x plus 25 going to factor into? That'll factor into what? X plus 5, or what's another way to write x plus 5, x plus 5? x plus 5 squared. That's what you want to write it as. Now, add together what's on the right-hand side. What's negative 24 plus 25? 1. We just practiced solving equations by isolating the square. Now you have an equation that you can solve. How can you get rid of the square? What can you do to both sides? You can take the what? Square root. So you're left with x plus 5 is equal to plus or minus 1. Any questions, guys? So again, the idea is you create that perfect square trinomial and you get that binomial square. That's completing the square. So again, we can break this up into x plus 5 equals 1, x plus 5 equals negative 1. So what's x going to be equal to? X will be equal to what? X will be equal to what? What will x be equal to, guys? Minus 4, and x will be equal to what? Negative 6. Okay? And that's how you do completing the square. Okay? Any questions on that? Let's look at another one. X squared plus 4x minus 1 equals 0. So what's going to have to be the first step? First of all, do I want a 0 one side, or I need to move my constant over? What am I going to do first? Move the constant over. So I have x squared plus 4x, and I always like to leave a blank when I'm completing the square, equals 1, and I draw the same blank as a reminder to add the number to both sides of the equation. So now to complete the square, I take the number in front of x. What am I going to do with it? I'm going to take 4 and do what with it? Divide it by 2, and then I'm going to do what? Square it. So what's 4 divided by 2? 2. And 2 squared is? 2 squared is 4. So I'm going to add 4 to both sides of the equation. So now I want to factor the left-hand side. What does x squared plus 4x plus 4 factor into? That factors into what? X what? X plus 2 squared. Equals, what's 1 plus 4? 1 plus 4 is 5. So now you're ready to go ahead and solve it. So what are we going to do to both sides of the equation? You're going to take the what? Square root. So x plus 2 is equal to plus or minus square root 5. And then finally, to get x by itself, what am I going to do? I'm going to subtract 2. So x is equal to negative 2 plus or minus square root 5. So in number 14, guys, this is the one where you cannot solve it by factoring. You cannot solve it by isolating the square. Up till now, you would have had to use quadratic formula. But think about the quadratic formula for a minute. This answer, you'd have a lot of simplifying to do with that fraction and radical to get it down to this. Completing the square gives you a much more simplified answer. Because I know that I'd have a denominator if I had to solve this by quadratic formula. I'd have to simplify the radical. I would then have to simplify the fraction. Completing the square gives you a much more simplified answer. You don't have to do as much simplifying. All right, let's take a look at another one. You guys go ahead and try 15 for me on your own. All right, now, before we do the last one, I want you to pick up on something. So go back to number 15 for a minute. Go back to the step where I asked you to take 6 and divide it by 2. We all got 3. Correct? When we end up factoring this as a binomial to the second power, what number went inside the parentheses with x? Notice it was the same number I ended up squaring. Go back to the previous example, number 14. When we took 4 and divided it by 2, we ended up with a 2. Notice when we factored it into a binomial squared, we ended up with that 2 inside the parentheses. Notice, in the previous one, the first one we did, same thing. Now, the reason why I'm bringing this up is to help us with the next one, number 16. So, when the coefficient of x is not an even number, it's an odd number, you can still use completing the square, but you're going to end up with a fraction. But you can still follow the same process. Again, the first step is you're going to add 1 to both sides. Remember, you always want to take your constant and move it to the other side first. So x squared minus 5x, and I like always to draw that blank, equals 1 with a blank there. The blanks help to remind you to add the number to the same side of the equation. It's a visual reminder to you. So now remember, I need to take the coefficient of x. I'm going to take negative 5, I'm going to divide it by 2, and I'm going to square it. Well, how do I square a fraction? I square what? I'm going to square the numerator, and I'm going to square the denominator. So what is negative 5 over 2 squared? That's going to give me 25 over 4. So that's the number I'm going to add to both sides of the equation. So any questions on where I got the 25 over 4 from? Now remember, we know we want to factor the left-hand side. And you guys, we never factor with fractions, which is why I brought up recognizing those last 3 examples. I said, hey, what number did we square? What number ended up going inside the parentheses when I factored it? Remember, to factor this, look at this number that you squared. That's what's going to go inside the parentheses, just like in those other 3 examples that I pointed out. So whatever value you square is what goes inside the parentheses with x, because that's the square root of 25 over 4. Okay? So any questions on that? So again, like I pointed out to you a few minutes ago in the last example, I took 6 and I divided it by 2. I end up with 3. Whatever, and notice when I factored it, that 3 ended up in the parentheses. That's not a coincidence. That will happen all the time, whether it's an integer or whether it's a fraction. All right? Equals. What is 1 plus 25 over 4? It's going to be what? 20. Well, 1 is actually 4 over 4. So 4 over 4 plus 25 over 4 is 29 over 4. So now what am I going to do to both sides? I'm going to take the what? Square root. So I have x minus 5 halves is equal to, again, plus or minus. Remember, when you have a fraction under a radical, you can take the square root of the numerator and divide it by the square root of the denominator. So nothing I can do is square root of 29, but what is the square root of 4? 2. Now what can I do to get x by itself? I'm going to do what? I'm going to, how do I get x by itself? I'm going to add 5 over 2 to both sides. So there's your answer. Okay? So like I said, if that coefficient of x is odd, you are going to have some fractions to contend with. Okay? So any questions on completing the square? All right, let's take a look at your homework.